How's it going, Mathaholics? Today we're going to be talking about representing linear non-proportional relationships. So, what do all these fancy words even mean? A linear relationship simply means whenever I graph the points that I'm given, I get a straight line. That's it. So, if you're talking about money or food, whatever it is, when you graph it, you get a straight line. All it is, nothing difficult about that. Now, a non proportional relationship, as we see right over here. I can't tell you what a non proportional relationship is without telling you what a proportional relationship is. So, over here, I wrote down the requirements in order to have a proportional relationship. I recommend that you write those down just because you'll probably need them later on. But the two requirements, as you can see right there, we need to have a constant slope and the line needs to go through the origin. Okay, that being said, let's graph this y equals 2x and see if we have a proportional or a non-proportional relationship. Now, as you can see here, we're not given any points, so we have no idea how we can graph this y equals 2x. And if you already know how to graph the y equals 2x, then go ahead. But I will tell you, when I was learning this stuff, I was not sure how to graph points unless I was given points. So I'm going to tell you a little story. One time, my family took a trip to Puerto Rico, and the house we were staying at had a really big orange tree right next to it. That tree was full of oranges. And I told my little brother to go climb the tree and get me some oranges. And you know what he did? The exact opposite of what I told him to do. He did not get me any oranges. So what option did I have? I had no other choice but to go get those oranges for myself. So that is what I want you to remember whenever you need to graph something and you're not given any points. When we're not given what we want, we need to go and make them ourselves, or we got to go and take them for ourselves with, with an exception. You know what I mean. Anyway, so now that we aren't given any points, what do? We are perfectly allowed to make our own points. So we have y equals 2x as our equation. And now let's start picking some points. So let's go ahead and pick some basic ones. Let's go with -2, -1, 0, 1, and 2. Pretty easy. And now what do we do with these x's that we just picked? As we can see up here, I wrote our equation, y equals 2x, and now we just plug each of these x's into our equation one by one and see what we get. So when we plug -2 into y equals 2x, we get a -4. When we plug -1, we get a -2. When we plug in a 0, we get 0 because 0 times 2 is 0, or 0 times anything is 0. And then when we plug in a 1, we get a 2, and when we plug in a 2, we get a 4. So now we have points, and we can plot them. Let's go ahead and plot all our points, -2 and -4. Here's a -2, down to -4, -1 and -2, 0 and 0, 1 and 2, and then 2 and 4. Alright, and now let's draw a line. And if you've been watching some of these videos for a while, you know that I complain about not being able to draw straight lines a lot. So I actually figured out that I don't need to draw my lines anymore because there's a little feature on here that does them for me. There we go. And let's make it bold in a different color just so we can see it a little bit better. Okay, well, it doesn't want to change colors, so we'll just leave it blue for now. Okay, now let's go back and look at our requirements. Constant slope. Let's check our slope. So we could do it a couple of ways. In the last video, I did the y2 minus y1 over x2 minus x1 method. So today I'm going to switch it up a little bit and do rise over run. Let's see, I'm going to start right over here. We go up 1, up 2, over 1. So that's 2 over 1. Let's pick some other points. I'm going to start down over here. Up 1, up 2, over 1. We also get a 2 over 1. And you can keep checking if you want to. I happen to know that this is a constant slope just because I made this problem up. But in case you really wanted to check, feel free to pause the video and check for yourself. Unless I made a mistake or something, but I'm going to say I didn't this time. Perfect. We know that it has a constant slope, so far so good. And then the second thing that we need to check is, does this line go through the origin? Remember, what is the origin? The origin is simply 0, comma 0. And you can check, yes, it does go through the origin. Now, quick question. Let's say I did not draw my point perfectly today, and I drew it somewhat over here. And you're like, I'm not, or somewhere here, you're like, is that 0, 0, or is that 0.5? What's going on here? If you're not sure, don't guess. Just look at your little points, and you'll know for sure. Here we know for a fact it passes through the origin because we plotted the points 0, 0. So the answer to question number 1 would be proportional. Okay, now let's go on to number 2. Y equals x plus 2. What do? We are given points, so let's go ahead and plot those. -2 and 0, let's start with those. Left 2, don't need to move anything. -1 and 1, -1, 1. 0 and 2. 1 and 3, 2 and 4. All right, so now we can check. Let's draw our little line. Not draw, because we know what happens once I do that, but insert. There we go. And this time I was able to make it black. Fascinating. Let's look at our requirements one more time. Constant slope. Let's see, do we have a constant slope? Let's go and check. How do we check for slope? There's a couple ways of doing it. We could do y over x, or we could do y2 minus y1 over x2 minus x1. In this case, I'm just going to do y over x. Or we could do the rise over run, but I did that in the last problem. So 0 over -2. Okay, what does that really tell us? We might not be able to tell right away, so let's keep trying. 1 over -1. I feel like this method might be a little more confusing, even though sometimes it's easier, so I'm going to do y2 minus y1 since there's different ways. 1 minus 0, because this is going to be the second y, the first y, over -1 minus -2. Let's see what we get. 1 minus 0 is 1, and then -1 minus -2, two negatives, that just turns into a positive. -1 plus 2 gives us 1. So we get a 1. Let's try again. Let's pick some other points. Let's work with these over here. 4 minus 3 over 2 minus 1. That's going to give us 4 minus 3 equals 1. 2 minus 1 equals 1, and there we go. Now, another way you can tell if it has a constant slope is if the line is completely straight. And in this case, it is, but sometimes it's a little hard to tell. So that's why I recommend you you do the y2 minus y1 or the y over x. And you can keep checking all the points if you want to, but like I said, I made this problem up, so I do happen to know that the slope is constant. Feel free to pause the video and check for yourself though. So we know that we have a constant slope. Now what is the second requirement? Let's go back up. Needs to go through the origin. What did I say that the origin was? 0 and 0. Let's go look at 0, 0. Does not look like anything is going through it there. So unfortunately, this is not a proportional relationship. If it's not a proportional relationship, what does that mean it is? Non-proportional. All right, pretty simple. Let's go on to the next one. And believe it or not, they don't get any more difficult than this. You might get an equation such as y equals x squared plus square root of something. But besides stuff like that, which you'll practice and you'll get good at, it doesn't get any more difficult, I promise. This time they heard what we were saying about the oranges and they didn't want us to go pick our own oranges, so they gave us the points. Since they're so nice to us, let's start plotting these points. -2 and 1. And one more thing, I don't want to call it a cheat sheet because I mean it's not a cheat, but it's a little tip and trick. If you don't really want to sit here and plot the points, you know one of the requirements to see if it's proportional is if the line goes to the origin. What is the origin? 0, comma 0. Look at these points. At 0, y is 3. At x is 0, y is 3. So we already know that it's not going to go through the origin. So without even graphing it, we know for a fact that this is going to be non-proportional. But just for the sake of the video, I almost wrote non-profitable. There we go. Just for the sake of the video, I'm going to go ahead and plot these points. So we already have -2 and 1. Now let's go -1 and 2. 0 and 3. 1 and 4. 2 and 5. We're going to draw a straight line. So far, so good. Not gonna lie, we all know this is the best line I've ever drawn on the Mathaholics. So sure, this has a constant slope. It's a straight line. We could check our rise over run, which let's go ahead and do that. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Constant slope. Does the line go through the origin? It does not, so it is non-proportional. Now, one more thing I want to say, just because in all these examples, every single line was linear, do we see this 5 right over here? Let's say it was a different number, such as literally any other number. Let me just delete that 5. Hey, Steph, give me a random number. 7, okay. So this is going to be a 7 now. And let's delete that point that we just made at 2 and 5. Here it was. And let's put it at 2, comma 7. I'm going to have to delete this entire line. 2, comma 7. 7's all the way up here. No matter how hard I try to draw a straight line, it's not going to be possible because it's not linear. You see, this line goes on forever in both directions, and it's never going to touch our 2, comma 7. What does this tell us? This tells us that we don't have a constant slope. Now, I'm not sure if you'll ever see a problem like this because the title of this is literally called linear non-proportional or linear proportional. So I don't think they'd throw something at you that isn't linear, but I figured I would just better teach you it now as opposed to seeing it on a test and not knowing what to do. So I hope this video was helpful. And if you did enjoy it, I'm not even going to sit here and ask for likes or subscriptions. I just hope you do well on your homework and on your tests. Have a great rest of your day.